When writing formulas for your binary covalent compounds, remember those are between your two nonmetals, the molecules containing the same elements can combine in more than one way. So you have CH2O, C3H6O3, C6H12O6. They're all the same elements, carbon, hydrogen, oxygen. Because when you have covalent compounds, they're not going by charges anymore. They're not making those ions and then being attracted by the positive and negative. They're sharing those electrons instead, so they can share multiple different ways. So when you're writing the formulas for the covalent molecules, you don't want to put it in the lowest whole number ratio. You don't want to reduce it down. So I don't want to reduce the 6, 12, and 6 because it's completely different than C3H6O3. You're also going to use Greek prefixes from the name of the compound to tell what the subscript is. For example, dinitrogen tetroxide. Di, if I look over here, means 2. So I have 2 nitrogens, and tet means 4, so I have 4 oxygens. So it's actually a lot similar than naming ionic compounds because you literally just look at what the prefix is, and then that tells you what to make the subscript. If the first element doesn't have a prefix, you're going to assume there's only one. So they don't have to put monocarbon dioxide. They can just put carbon for that first element to say that there's just one carbon. So that's a clue there. But otherwise, you just look at what these prefixes mean, and that tells you exactly what your subscript will be for that element in the name. And then you put it in the same order that the element is listed in the name as well. So looking at the names, we're going to try to write our formulas here. Nitrogen trifluoride. There's no prefix on this nitrogen, so I'm assuming there's just one of them because it didn't specify. So I have nitrogen, which is N, tri, which is 3 fluorines, so NF3. Disulfur dichloride, so I'm going to have 2 of each. Sulfur is S, so I have S2. Chlorine is Cl, Cl2. Dinitrogen tetroxide, 2 nitrogens, N2. Tetraoxide, 4 oxygens, N2O4. Phosphorus pentafluoride. Again, there's no prefix on the phosphorus, so I'm assuming there's just one, so I have P. Penta, if I look it up, if I need to, is 5 fluorines, so PF5. Now when you're naming them, you're going to do the exact same thing but flip it backwards. There's a couple more steps just based on the rules, but the key thing here is just to put the prefix and leave it as is when in doubt. So write the subscript of each element from the formula as a Greek prefix in the name of the compound. So the only thing we have to worry about is I just look at the formula here. I have 4 phosphoruses. 4 is tetra, so I have tetraphosphorus. And then I have 8 oxygens. 8 is octa, so 8 oxide. Oxide. So notice I'm still switching the ending of the second element to "ide," just like in my ionic bonding. So I'm still switching that second one. They should all end in "ide." A couple things, if you have the first element, if there's only one of them, you don't have to put mono. So like this second example here, SF6, I just have 1 sulfur. I don't have to say monosulfur. I can just write sulfur. If I have one of the second element, like here, N2O, I do have to put mono here just in case. But for my first element, if there's only one of them, like the sulfur here, I don't have to put mono. If the second element has only one atom, you have to use the mono in the name. So here are examples of both of those taking place. N2 dinitrogen monoxide, SF6 sulfur hexafluoride. Given the formula, you want to name the following molecular compounds. N2O, 2 nitrogens, 1 oxygen, so dinitrogen monoxide. PCl3, phosphorus. I don't have to put mono in the name of this one. There are 3 chlorines, so trichloride. Remember, I'm putting the ending as an ide. Sulfur hexafluoride. There are 6 fluorines, so sulfur hexafluoride. And carbon disulfide. So there are all the examples, kind of, and some practice ones. There are a couple more things you want to remember, but that is pretty much the basics and basis of all of naming and writing formulas for covalent compounds. They are much easier than the ionic compound rules to follow.